So in this class, we are going to discuss about some. We are going to solve some problem, and then we are going to learn about some basic how to find that shape function for 2D like rectangle element by using this method, Lagrange polynomial. Okay. So in last class also I told you about that how to find that shape function for any this constant strain triangle. So we call that like CST. So it is having like node 1, node 2, node 3. So how to find, I already discussed you last class. So in this class, we will see how to find by using this Lagrange polynomial method. So let's start with one-dimensional element. So this is one-dimensional element. So this is a general formula for to get the that shape function by using Lagrange polynomial. Okay, so this is general formula. How, where, what is x? So like for example, we are having one element. So this is 1D element. So we are having one element like node 1 and node 2. Okay, so this is x direction. And I want to find that shape function for node 1. So like this is n1 shape function. This is n2. Someone calling like some other people calling like psi shape function, psi 1, psi 2. Okay. So this is a length L for any element, and at node 1 we are having x1 equal to 0 and x2 equal to some L, length L. Okay, or then we can, what we can do, we will not assume any like we will not specify any length. Just we will write coordinate to x1 and x2, x1 and x2. Okay, and I want to find that shape function for this element. So how I will find, for like I'm going to write n1. What will be n1? N1 will be n1 equal to x minus x2 divided by x1 minus x2. Okay, this will be n1. And what will be n2? What will be n2? N2 will be n2 equal to x minus x1 divided by x2 minus x1. So, hello, Deepak. Can you hear me?
Yes, sir.
Okay, good. So, in this class, we are going to learn how to find that shape function by using this Lagrange polynomial technique or method, and then we will solve some problem, and we will solve some problem like those given in assignment. So you will get some more idea how to solve this type of problem. So like this is a general formula for one dimension 1D element. So like for example, we are having one element. This is having node 1, node 2, node 1, node 2, then node 1, node 2, and this is x1 coordinate, or this is x2 coordinate for this. This is a length L. This is in direction of x. So I want to find shape function. So what we learned in last class, like for n1 equal to, I want to find shape function at node 1. So n1 equal to x minus x2 divided by x1 minus x2. Like this we have to write. Similarly, what will be n2? So n2 will be x minus x1 divided by x2 minus x1. So this will give us that shape function n2. And this is in general how we can write. So like we are having more than 2 nodes. So like in this we are having only 2 nodes. So we are having more than 2 nodes, like node 1, node 2, node 3. Node 1, node 2, node 3. So by using this summation, we can find that shift function for other nodes. Okay, so for example, in any case, we are having a number of node 5. Okay, so we are having number of node 5. So let me draw that one element. So I'm having total node 5. So node 1, node 2, node 3, node 4, node 5. 1, 2, 3, 4, 5. So total 5 nodes I'm having. And what I'm saying, I want to find shape function for this for this node number 3. So I want to find shape function for node number 3. I want to find n3. So how I can find? So what we have to do, one thing we have to remember, like for whichever element we want to find, so we have to keep that below. Like for example, I want to find for node number 4. So this is like n4. So what will be n4? N4 equal to, we are having total 5 nodes. So x minus x1, start from x1, then x minus x2, x minus x3. Then we don't have to write x minus x4. We have to write here x minus x5. Okay, we didn't write in here x4. So in bottom we will write x4 minus x1, x4 minus x2, x4 minus x3, and x4 minus x5. So like this we can write for that node number 5. So this is, sorry, node number 4. This is shape function for node 4. Similarly, if I want to find for node 3, so node 3, see, x minus x1, x2, we didn't write 3. We are going to jump to 4. So 4 and 5. But in bottom we are going to write x3. So x3 minus x1, x3 minus x2. Then here again we are not going to write x3 minus x3, because we cannot. If we are writing x3 minus x3, this will become 0. This is not feasible. Then x3 minus. Oh, Deepak, are you getting? Hello.
Sir. Yes, sir.
Okay. So like this we can write for any 1D element. So like we are having more than 10, 20, whatever. Just we have to remember this, how we are going to write. Okay, so for example, as I told you, for 2 node bar element, for example, 2 node bar element. So we are having total nodes. Here also I just missed one thing, like here, this is number of node, or node number, like yes, number of node, and this is like what we call like interested node. For which node, at which node we have to find that shape function. So for example, in this case, we are having this 2 node elements. So node 1, node 2. Okay. And so what will be total number of node we are having? 2. So this will be 2. So this will be about 2. And at which node you want to find that shape function? So for example, I want to find at node 1. So k will be k equal to 1. So here also you can put here in this formula also, but no need to remember that formula. Directly we can write like n1 equal to x minus x2, because I am going to find n1, then x1 minus x2. This will leave her. And we know that if I will say like this is x1 and this is x2, if I will say this is length L, then x2 minus x1 will be L. So in simple form, how we can write? So n1 will be x minus x2 by L. Okay.
Yes, sir.
Then similarly, what will be n2? N2 will be x minus x1 by L. And if I will say in other condition, like in further assumption, if I will say, for example, x1 equal to 0 and x2 equal to L, for example, so what will happen? So this one, so this one will become n1 equal to x minus L by L will become like x by L minus 1, and this will become this x minus 0 by L. Yes, no, yes, yes, yes. Correct?
Yes, sir.
So you gone through those video in video lectures. You completed all these things.
Yes, sir. Sir, I have doubt in seventh question actually of assignment 10, seventh question.
I don't have that. Can you show me that? Okay, let me download. Can you show me that question?
Yes, sir. I can show you.
You can share your screen.
I just show you. Just
Regarding that question regarding some heat transfer, right?
sir, I have print out. I can share with you. I can show you that.
Okay.
Sir, is it visible?
Oh, wait 1 minute. Wait 1 minute. Let me. Yes. So, what is
We have 10
saying?
noded cubic triangular element and find the shape function corresponding to different nodes. We need at node number 5.
Okay, this question I will discuss it today. Okay, so okay, we are going to this question.
Yeah. Thank you.
So I'm just giving some idea, then we will go to that question. Okay.
Yeah, sir. Sure.
Okay. So like as of now, what we seen. So similarly for 3-node element, we can write for any node element. And one more thing I want to tell you, what is the property of that shape function? What is the property of shape function will be? For example, I'm interested to find a shape function at this node. So the shape function at this node for this will be 1, and this will be 1 for that n2 will be 0 at this node 1. For example, at node 2, so we are having, this is 2-node element, so we will have total 2 shape function.
Yes, sir.
So for example, at node 2, what will be shape function n1? N1 will be 0.
N1 will be 0, N2 will be 1.
N2 will be 1. This is property of shape function.
Yes, sir.
Then coming to here, so this similarly for this 3-node element, this is also similarly for 3-node element, we can get that shape function 1, 2, 3 by using that same concept by using Lagrangian polynomial method. Okay, one more who joined Adhya. Let me see. Abhinya, you have done any doubt? Abhinya, can you hear me? Okay, maybe she not able to hear me. So similarly for 5-node element, like we can write all shape function by using same concept. So this is like for variation of n1, then n2, because every time like n1 will be 1 here, and everywhere it will at other than node 1, at each node it will be 0. So it will go like this. Similarly, for node 1, this is for node 3, this is for it will be 1 here at node 3. Apart from this 3, at each node it will be 0. So these are the property of that shape function. Okay, done. This is not required. So or should I explain that? You know that Deepak, how to find that shape function for triangular element?
Yes, sir.
Okay, then we will go to
For quadrilateral, I can do it. No issue.
Okay, you can do that also. So like for how we are doing for quadrant element, like for example, I want to find shape function for this, like for node 1, I will say node 1, 2, 3, 4. So how we'll find? So for node 1, x comma y equal to node 1 in x and shape function in x and shape function in y. Like that we have.
Why? Yes, sir.
So like simple as we did for linear also, just only we have to include one that y effect also, because at node 1 this is having this effect and this effect. So
Yes, sir.
x and y effect. So this is not required directly, we can go to solve some problem. Okay. So I have I taken some problem, and like this problem they are going to ask in your assignment and other Qs also, maybe in your last exam. They are not going to ask any in depth, but that question will be conceptual. So start from this question. First question. Suppose shaft is subjected to torsion, okay, and we are interested to find the solution with the help of APM. What will be governing equation of torsion problem? Psi is stress function, and omega is the domain, tau is the boundary. So what will be solution? Anyone want to give comment? First one, but why? Any reason?
Sir, in that equation, heat conduction equation, we'll put that and simplify it. So F will be -2. And on boundary, it will satisfy the condition, so it will be 0 on boundary.
Yeah, good. No need to teach you. Then coming to next.
Actually, I have learned from video lectures all these.
Okay, so this is second question number second. Suppose answer I don't want to show you. Suppose this is, I think anyone can solve who did that UG in a first in second semester, second year we are studying about that stress strain.
Yes, sir.
So for example, we are having one that rod of some shaft, and what is it? T equal to torque equal to 2. I forgot that formula. Yeah. T by what is the formula of torque? Like M by I equal to sigma by pi E by R. So I want to find shear stress. What is the formula of shear stress? Deepak?
Shear stress.
Some tau equal to 64 pi by 64, something like this.
Yes, epsilon xy or epsilon.
Epsilon. Yeah, it's okay. But I know this variation of the shear stress with radius.
Directly proportional to that. Yeah.
This one I know. I forgot the exact formula.
No problem. That is directly proportional to that.
Yes. So these are cannot possible. So only that.
Okay.
Now coming to see like type of question they are going to ask in your exam, not that.
Yes, sir.
In depth.
Okay.
Now coming to this question, suppose we are solving one torsion problem in APM that we don't have the exact solution. Okay, we don't have exact solution. We are starting with very coarse mesh and we want to freeze the number of mesh. Okay, how to choose the correct mesh size? That one you have to solve. Like how to choose that correct size? Can you want to guess? So we are having four options.
The third one is not possible. C option. In this
APM
case,
solution for torsion problem do not depend on mesh size, so we cannot choose any. This is not nothing. What is he saying?
Yeah, so it should not be there.
This is not.
clearly. Yeah. And second also should not be there.
We will solve
We
another
will
depending problem with
we will
similar.
if we will solve another, so there is no more direct relation for this one.
Then okay, two option gone. Now remaining two.
Yeah. As per my understanding, the first one should be there. We will plot the response of some selected critical points.
Then
When the
the
response
response.
don't change with increase with the mesh size, then we can take the mesh
Uh,
number as
so,
final.
like for example, I'm having. I want to find displacement for one cantilever beam like this, or
Yes, sir.
any beam. So what
Any
we
beam we
are
can
in
take.
APM, what we are doing, we are doing meshing. So we are dividing this element in number of small this member
Yeah.
in number of element like this.
Yes.
And for example, I am putting load at this location. So this is my critical location like
Yes, sir.
C. This is load P. So what I will do, I will take I what I will do, I will check response at this point. Like for example, I'm putting load. This is like mesh size, and this is that displacement. I will write like by. And what I will do, I will change mesh size. Like for example, first I'm taking 10, then 20, 30, 40, 60 like this. Normally, what
Yes,
we
sir.
are doing, we are starting with coarse mesh. Like you know that coarse means, dude, like we are having some
The
space.
gap, a long gap is
Long gap. Length is very not like when we are
large.
having between two element, we are having between two node
At
we
least
are
little
having.
large in comparison to a simple
Yes.
mesh.
So like we are having like terminology like coarse mesh or
Yes, sir.
fine mesh. So coarse mesh and fine mesh. So normally what we are doing, we are starting with course mesh. If like for example we are having
Yes.
different, I will tell you like we are having different software like ANSYS, Abacus, COMSOL. These are
Yes,
different
sir.
FEA solver like finite element method they are using, and they are giving solution for different structure, different problem. Even though heat transfer also we can do. So normally, like computational time of that problem depending on mesh size. So, for example, we are having very fine mesh size that computation that software will take so much time to solve that problem. So normally, what we are doing, we are starting with codes, and we are doing that. We are calling that convergence study for different. We are taking first that five, then six, like five, four, three, two, one. For
Yes, sir.
example, then I'm plotting. I start with like three mesh size. Then I got some response at this point, something value. Then I seen that I went to two. Then I seen I got some other response. Then similarly one I got some. After certain that mesh size, this displacement will not change. This one will not change.
Yes, sir.
So what we are seeing, like we did convergence study, and we will keep this size our that element size. Okay.
Yes, sir.
So normally, like if we are doing any FEA problem or any finite element method, this is the main concern: which size we should select. We don't know
Yes.
like how to select size. So normally, for example, for simple beam also, we are doing convergence study for that mesh. So this our option A will be correct. Okay.
Yes, sir.
Now suppose we want to construct a shape function. Okay, for cubic triangular element, then what will be approximate function to based on. कहाँ पड़ गया? What will be the approximation function to be used to construct this shape function? This one I think you know what will be answer.
D should be there. The complete cubic polynomial.
But like how we how we are getting this function?
Sir, by we are writing like in binomial we are making a triangle 1 1, then
Like this. This is called
that
Pascal triangle.
yeah, Pascal triangle.
Pascal.
So
Pascal. Pascal triangle. I don't know. So like first we are
yeah,
writing 1, then x, y,
1
then
1 by x y, then x square x y x
x
y
square x,
square.
y, then by x, y square, like this, no?
Yes sir, yes sir.
So this our D will be correct. Or we can eliminate also some option. How we can eliminate? So how we can eliminate? This one, this will not be there. This will not be there. Out of C or D, one of the there. So then we have to use some of our mind, which one will be correct.
Yes sir.
So this option D will be correct. Now question number 5. This one I supposed to give me. Can you solve me? I yes, wait for
Sir,
few
this
minutes.
we can find out by a1 by a area for first one, then a2 by a and
Yes,
a3 by a.
correct. So like we will make this one like
Yes
this.
sir.
So this is node 1.
Yes
So
sir.
opposite to node 1 will be area A1.
That will be a1
Then
opposite to
this will
a2
be A2. This
and
will
then
be
a3. Then
A3.
we will divide every area by total area A and we will get that.
So what will you by total area? So total area will be
Half of
111, half of 111.
yes sir.
Then
Then 0 x1
0.
is 0, y1 is also 0.
Okay, so we are calling this we are, so this one x1 0,
Yes sir.
x2 we are having 5, x3 we are having
X2
0.
5 and x3 0 again.
Then 0 0 4.
4.
So this will be 9 by 2.
So ultimately in this case we will get
20 by
10
2.
10.
10. Yes. This will be our total area. Then what about that A3?
A3 will be
1 by 2.
111 half
111. 111.
then
Then
A3
0
0
5 1
1.
0
Yes
0
sir.
1. Correct.
Yes.
So
So it will
A3
be
will be 5 by 2.
yeah 2.5 right. 2.5 divided by 10, then we will get 0.25.
So then our third coordinate will be
0.25.
so how we will divide? I will write like
2.5 will divide by 10.
C3 equal to 2.5 divided by 10.
Divide by 10. That is 0.25.
0.25. Any option matching?
So B option is there. Last
This one
one is
only
only
matching. So no need to calculate other.
yeah.
So this will
So
be
that is
now coming to sixth question.
this is similar simple you have discussed earlier. We'll write down like Lagrange polynomial
So
for
Lagrange
that.
polynomial are used to polynomial. Okay, suppose we have coordinate. Okay. These point
So
can be
numerator
connected.
should not contain x minus x2 because we are finding L2.
So which one we have to find? How we are finding L2. So it should not be x2 minus x2 minus.
Yeah. So the third option will be there.
X minus x2 should not be there in.
Yeah. Third one.
So like this cannot. This one also. This one. So there
Third
C
option is
option.
correct.
C option will be correct.
Yeah.
Now coming to this question you discussed now.
Yeah. In this case, in this question, I have doubt.
So
I have told I got that 9 by 2 L1 L2 into 3 L2 minus 1.
Okay, so let me check. Question number 7.
Yes, sir.
First thing we have to find coordinate.
Yes, sir.
Like first we have to find L1, L2, L3.
Yes, sir.
Right? So like for this point,
sir, we have to find on node 5.
Okay, but we have to find for node 5. Okay, but we will first we will find L1, L2, L3. So L1, L2,
L2 and
L3.
L3.
What will be L1?
L1 will be 1 by 3 in this case.
So like A1 by A total,
Yes, sir.
right?
Yes, sir.
Correct, na?
Yes, sir.
A2 by A total, A3 by A total.
ठंडा हो जाए फिर अच्छा नहीं लगेगा प्लास्टिक में उसको निकालिए
And one more thing also we have to remember for node 5,
Yes,
what
sir.
will be L1, L2, L3?
L1 will be 1 by 3 in this case.
L1 will be how?
Because L1 will be 1 at node 1, right? And L1 at node 2 is 0.
L1 at node 2, 0. Yes, correct.
And we are taking, sir, point at 5.
So like this is 1 by
that
3.
will be 1 by 3, 2 by 3, and 1.
3. This is 1 by 3.
2. Yes, sir.
Total is 1.
So that will be 1 by 3 at that point. At node 4, it should be 2 by 3, and at this one, at node 1, exactly 3 by 3 means 1, right? So L1 I will get as 1 by 3.
At node 5 we are talking about, na? At node 5.
Yes, sir. Yes, sir.
So at node 5, L1 will be 1 by 3. I'm getting correct. Then what will be that L2?
Sir, L2 is 1 in this case.
L2 is 1. How?
Sir, this is throughout this line L2 is 1. No, something I done wrong in this case. L2.
We have to go through, I think, from basic. That will be easy.
Yes, sir. Sir, we are writing shape function as L1 minus S naught, L1 minus S1 like that. Up to Sk minus 2 if K partition we are taking.
Like this also we can write. But for not for this, because this is triangular element, so we have to go X by also.
Okay.
For this, we are using that area function like this. Like this, we are calculating. Wait 1 minute.
Okay, sir. Then please.
Let me check my notes.
Sure.
I think first we should find L1, L2, L3. Okay, so
yes, sir. Sir, in case as you are telling us that A1 by AT, A1, then we need coordinate of this. Those are not available.
so by using we cannot by using this we cannot get, no, right?
Yes, sir. Yes, sir. Directly we have to find out the values on that point.
Correct.
Like I got that L1 is 1 by 3. L1 is 1 by 3 and L3 will be 0.
Yeah, L3, this is correct. L3 will be 0 here.
And L1 will be 1 by 3.
Only we are concerned about L2.
L2.
So where is L2? Where is L2? So this is L2, L3, L1, 2, 3. So here L2 will be 1. Can you see here?
Yes, sir.
This is L2 equal to 1.
And at node 1, L2 is 0. So it will be 2 by 3.
Then
L2 will be 2 by 3, sir.
this one, this one. How you got?
Sir, L2 is 0 at node 1.
Yes. Yeah,
And L2 is 1 at node 2. So if I will move from node 1 to node 2 on 4, node number 4, L2 becomes 1 by 3. On node 5, L2 becomes 2 by 3.
Yes, L2 will be 2 by 3. Correct.
And L3 will L2 at node 2 will be 3 by 3. That is 1. Am I right?
Yeah, correct. This L2 will be 2 by 3 here.
L2 is 2 by 3, L1 is 1 by 3, and L3 is 0.
L3 at node 5. This
5.
is at node 5.
Yes, sir.
At node 5. Yes. But now we have to find that corresponding shape function.
Yes, sir.
5. How we will get?
So then after, sir, we can put it in that formula for Lagrange method we are writing.
Yes, so we have that formula in form of L.
Yes, sir.
This one we can use, no?
Yes, sir.
But like these are we are using if we are having coordinate, but we are like here, in this problem here,
yes, sir.
Like we are talking in the form of that L. So those formula we cannot. I think it will not be easy to use here.
It is not useful.
It will be difficult, but we can use. But I think I will suggest to.
Sir, we have used pi fj by fi, that kind of formula we can use here.
Yes, that one we can use here. So let me get one page.
That we are writing L1 minus S naught.
Yes, that one we can use.
That one we can use it here. So in this case, sir, that will be L1 minus 0.
Let me write. So
yes,
at node 5. At node 5. So like we are having psi 5.
Yes, sir.
Equal to L. What will be L2 minus
L1. L2 minus 0.
Okay, we can start with L1. L1 minus 0. Then
yes, sir.
L2 minus 0. Then
yes, sir. L2.
Then L1, L2.
Sir, L2 minus then L2 minus 1 by 3.
L2 minus
1 by 3.
Wait. We are here. L1, L2. It should be L1. It should be L1 minus 1 by 2 by 3.
L1 minus 2 by 3.
L1 minus 2 by 3. Then L3 minus 1 by 3. Have I seen what you're doing? Yes. It is correct because I wrote in my notes like this.
Okay, sir.
Now we can.
And division we will write on 1 by 3 minus 0. Then again 1 by 3 minus 0, 1 by 3 minus 2 by 3, and 1 by 3 minus 0.
Do we have to write division? That I'm thinking.
So in this case, sir, we are writing these, and then that point minus like x2 minus that x naught, x2
that's
minus
x. We are not writing division here, no? Because we are using directly at area function, like in terms of
okay, sir. Got it.
So now it will be what will be? It will be L1,
L2, 3L1 minus 2.
Or like this also we can. Or see, now we have to multiply by some function, like some constant. So like I will see this is C1.
Okay.
C1. Okay. Then after putting that shape function boundary condition, we can get that C1.
Okay, sir.
So this will be our psi 5. So further we can solve like this is L 3 minus L1. But it will be 9 here. Then
Yes, sir.
it will be so it will be like 9. This will be 3. No, not 3. Sorry. This will be 3L1 minus 2, right? This
Yes,
will
sir.
be 3L3 minus 1. Then this will be C1, L1, L2. Okay. Now, yes, correct. Now we have to put that our shape function condition. How we can put? So at node 5, that shape function 5 will be 1, correct? This will be 1.
Yes, sir.
And we know that what the coordinate of shape that node 5, we are having L1 equal to, we wrote here,
1 by
L1
3.
equal to 1 by 3.
1 by
L1
3.
equal
L2 is
to
2
1 by
by
3.
3.
L2 equal to 2 by 3. And L3 equal to 0.
Yes, sir.
Correct? So
Yes.
we can put these boundary condition. So what we will get, psi 5 equal to 1, then L1 we are having 3. So 3 into 1 by 3 minus 2. Then 3 into 0, it will be 0 minus 1 divided by 9 into L1 1 by 3, L2 2 by 3 into some constant C1.
Yes,
So
sir.
how about we will got here from how we got? So this 9, 9, 9, it will become 81. 81 equal to, so this will be 1 minus 2, it will be minus 1. Correct?
Yes,
This
sir.
will be again minus 1. This will be 2 into C1. So our C1 will be, what will be our C1? C1 will be 81 by
81 by
2.
2.
Now after getting value of C1, we can put again in this equation.
So that will be 9 by 2.
This will be psi function or shape function 5 equal to
9 by 2. L1, L2.
Yeah, 9 by 2. This
L1, L2.
again
3L1 minus 2 into 3L3
3L1
minus 2.
3L1 minus 2, 3L3 minus 1, then L1, L2. Any option matching?
Yeah, second one.
Yeah, this is correct.
So 9 by 2,
Oh,
L1, L2,
not for
3L.
this option. Not for this option, sorry. For this option. Yeah, this will be correct answer. Right?
B1. Yes,
Now
sir.
you got na how we are solving.
Yes, sir, I got it.
Now coming to that for node
Sir,
10.
actually, we have to remember this relation psi 5 you have written somewhere
Like,
L1 minus 0, L2.
that I know that you can, but we are writing
Actually,
you can
sir, what I
remember.
did in my relation, I forgot to use L3 as L3 minus, I have used L1 minus 0.
Okay, correct. This
I
will
have
correct.
used L2 minus 0.
This is also correct.
And then I have used L3 minus 1 by 3.
You
But
forgot L1.
I forgot to use this part.
Okay, this you can. So
Yeah,
now
I
coming
got it.
to this.
Means I have to taken what I'm getting from this part. 1 point I have to taken in left of this, 1 point in right of that, right? Means
Yes,
at 1
yes.
by L, 1 by 3 I am. So 1 point in before that 0 and last 2 by 3.
Yes, correct. So now coming to this question number 8. We want to
Yes.
find for that node number 10.
Yeah, in the same question, node number 10. So it will be 27 L1, L2, L3. Last one.
Yeah, this one. This one you got, na? So no need to discuss.
Yeah.
Now coming to next question. So now we are having 8 node element, and what will be approximate function? So let me write that Pascal triangle here. What will be Pascal?
Sir, in case of a 8 node NPTEL element. So what we can do, we can take relation includes 8 unknowns.
8 unknowns.
So in that case, I will get option C.
Wait.
Because in first one I have 7 are unknowns, C naught, C1 and up to
This
C6.
like this is also like one way to get answer, correct? Why unnecessarily
That I have just taken one idea from that. That's why I'm discussing with you.
Correct only. Why we should discuss on why we should take unnecessary term, why we should invest. But let me write that Pascal triangle for this. So
Okay.
this will be 1. This will be 1. This will be our x by.
Yes, sir.
Then x square, x by
X y square.
Y square. Then x cube. X cube.
Yes, sir.
X square by. Then y square x. Then y cube. So then again x4. X4. It will be x cube by. Let me take the pen. X cube by. This will be x square by square x by cube, then by cube. Again it will be x5 x4 by x cube by square x square by cube x by 4 by square. What we have to remember, we have to keep that degree should be same. Like here we are keeping 1 1, it should be 1 1. Here we are keeping
Okay.
2, this would be 2. Here we are keeping 5, so this like 4 and 1 5, 3 and 2 5, 2 and 3 5. So that one we have to remember. So
Okay.
which option will be correct? You can check. This is for 8 node, na?
Yes, sir.
So for 8 node, like you like by looking option also you can say this will be correct answer, right?
Yes, sir.
So
Otherwise,
here,
symmetry is nowhere in this. Out of these 4 options, I got symmetry only in this mode.
Correct. This is correct only. I think this is our last question. Yes. So what is last question saying? Consider quadratic rectangle element and find the shape function of a node 9 with coordinate minus L by 2. This node we have to find shape function. How we can find?
Sir, in this case, we can find out like if we will take this in xi and eta.
Xi and eta also.
Then we can compare these values like coordinate for this h will be minus L by 2.
Or any other way to find?
I have just tried from that part. And I got last x by L square h square 2x minus L into h square minus 4y square.
Yeah, option is correct. So any other, I'm thinking to get answer by other way. Like for example, we are having this one rectangular element, node 1, 2, 3, 4. So
Yes,
for
sir.
node 1, we are having effect of this x and y. So now how we
Yes,
are
sir.
writing like n1 x comma y equal to like small nx and small n1.
And 2y.
So like this we can get, let's try. So this will be minus L by 2. So this is okay.
Y 0.
So here we will write coordinate. So this is L by 2 and?
No, so this is minus L by 2 and 0.
Oh, this is yeah, this is x, y. So this
because
will be
this is in left of that.
Wait. So this will be 0 comma L by 2. Oh, no, this is that way. So
minus L by 2 comma 0.
L by 2 comma 0.
Yes, sir.
Then what the coordinate of this this 1 is L comma H. No. This is minus L by 2 minus h by 2, correct?
Yes, sir.
Then what will be coordinate of 4? It will be L by 2,
Minus L by 2 and H by 2.
h by 2. Okay, so now about what we can write here. So let's talking about this nx. So small nx will be, I want to write for this. So these node 4 and node 5 will come to in picture. Node 9 and node 5. So it will be x minus x5, it is 0. Yes. Then it will come this node 7, so x minus L by 2.
Yes, sir.
Now this will be minus L by 2
Minus 0.
minus 0 and
Minus L by 2 minus L by 2.
minus L by 2 minus L by 2. What will
Yes,
be?
sir.
It will be x minus
Into
x by
2x
2.
minus L.
So this will be how much?
This will be, sir, minus L from last. So L square by
Minus
4.
plus L square by 2, right? So this will
Yeah.
be 2. So 2 will go outside. It will be L
2 by
square.
L
This,
square. Yes, sir.
correct, na?
Yes, sir.
Then what will we buy in y
Y
direction?
will be similarly y minus 0.
For this point,
Sorry,
na?
y minus
This will be y minus h by 2.
h by 2 into y plus h by 2
Y plus h by 2.
divided by 0 minus h by
0,
2 into 0 plus h by 2.
0 plus h by 2.
Am I right?
Yes.
Yeah.
So then how we can solve? So this will be y square.
Y square minus h square by 4.
Square by 4. And this will be?
And in division that will be minus h square by 4.
So effectively what will be 4 will go?
We can multiply. So in numerator we can write down h square minus y square. Yeah.
Correct?
Yes, sir.
Then it is in y. So we can write
If you
here.
multiply these two, we will get the same.
Yes.
So just multiplying n1x and n1y, we got the answer.
Yeah, I'm going to multiply now. So this is our n1.
Yes, sir.
So n equal to n1x n1y. But let me write here. And this is 2x x, or we can that multiply by 2, so it will be x. It will be x minus 2x minus L by L square. And it will be h square
minus 4y square by h square.
And we can simplify. How we can simplify? So which
So
form
this
they
is
are?
this is the answer, right? Fourth one. I got this.
Correct, coming, na?
Yes, so, exactly correct, sir. X by L square h square we will combine.
So we will multiply, or
we just write down x by L square h square into 2x minus L.
L square h square 2x
minus L into h square minus 4y square.
So this will be our, this is a 9, no? It is 9.
This is 5, 9. Yeah.
9. This will be correct answer. Okay, good. and your problem also solved.
Yes,
Then
sir.
I will give you one problem to you to solve here. Let me open some notes. This one done. Parametric. This one also okay. Anything else you want to discuss? In doubt?
No, sir. Thank you.
I will ask from other people. Anirudh, do you have any doubt? Nandlal Kumar. No one. You have any doubt, Nandlal Kumar?
Okay, sir.
No, you want to ask anything? I want to discuss. Then what we can do? Only 30 minutes, na? We are still having some time, right? We start at 8:30. When we start? कितना हो गया time? इंडिया में कितना टाइम हुआ अभी यार?
It's 7, sir.
हाँ तो 1 घंटा हो गया है. चलो then okay, we can close.
Okay, sir. Thank you so much.
Okay, thank you. Bye bye.
Thank you.